Hello everyone, I am Soumyashree Senapati, Assistant Professor, Vedang Institute of Technology. In this class, we will solve one different kind of numerical while our volume is changed, but we need to calculate the pressure. So, before going to solve the problem, we need to understand the question, what the question is giving us. Like a cylindrical cell, the length is given here, that is 90 centimeter. So, data L is our what? 90 centimeter. Next, what is given? 20 centimeter internal diameter. That means the internal diameter, that is D, equals to 20 centimeter. Okay. So, next also thickness is given, that is 8 mm. Right. So, next our what? Additional 20 centimeter cube of fluid is formed into the cylinder. 20 centimeter cube. In its unit, there is the representation that the volume, some amount of volume is given. What is given here? What it says? Additional fluid. That means if already V we will get from what? Pi by 4 T square into L. Okay, we will get V here. What it's asked that there is some additional fluid inside it. That means we have here del V. Right. So, del V is our 20 centimeter cube. Right. So, first question asked to calculate the pressure exerted by the fluid on the cylinder. That means question asked about to calculate P. Okay. And hoof stress. We already know what? The formula for EV. EV is your volumetric strain, is what? Del V upon V, right? So, we will write it as EL plus 2EC. In this numerical, we don't have our longitudinal strain and circumferential strain. So, we will calculate that now. Right. So, what is the formula for E suffix L? Sigma C upon E. As I have already said in case of our previous numerical, what? EL is smaller. So, the first term will be smaller one. That will be half minus mu. And plus 2 into here what? Circumferential strain. Formula for circumferential strain is sigma C upon E into what? 1 minus mu upon 2. We need to remember these two formula and formula for hoof stress and longitudinal stress. If we know those formulas, so we can putting these values, we can calculate the whole process. Okay. So, in this process, what is common? Sigma C upon E, right? So, it will be 1 by 2 minus mu plus 2 will be multiplied here. 2 minus 2 into 2 or 2 cancel will be cancelled. So, minus mu. Right. So, next we will get what? Half plus 2. So, we will calculate it here also. 1 plus 4, 5 by 2. So, it will be 5 by 2 minus 2 mu. Right. We can write that what? Del V equals to sigma C into V upon E 5/2 minus 2 mu. Also, we need to remember this. Okay. If we remember this, we don't need to follow this whole step. Okay. So direct we will put the formula here, and by putting the values, we will directly solve it. Okay. So now we can erase the whole term. The whole derivation is not necessary. If we remember the formula, so this whole derivation is not necessary, right? We got the formula for, excuse me, we got the formula for del V. Now by putting the value, what, del V sigma C into V by E 5/2 minus 2 mu, right? So what we can write in case of sigma C? Sigma C is equals to P d upon 2T. We can write it here. Right? So now we can put the values. So P will be there and D is what? 20 centimeter. So we have our E in mm square. E is our what? Young's modulus. So in mm square. So we need to convert these things into what? Into centimeter to mm. So it will be 900 mm. This will be 200. Sorry. 200 mm. Here T will be same as 8 mm but 20 centimeter cube. So we can write it 20 centimeter into centimeter into centimeter, right? So 1 centimeter is 10 mm. We need to multiply 10 into 10 into 10, right? So this unit change is very important. You need to remember all this process. So you can ask why centimeter, if centimeter cube we can write it as mm cube, but no. As centimeter cube or centimeter square is given, so we need to multiply this with when converting centimeter to mm, right? So now mm cube. So we got all our values. Now what? D is 200 mm, right? Here D is 200 mm into, we have not calculated our V value. So pi/4 into T square into L. It will be so we can write pi as 22/7 into 4 into 200 into 200 into 900. Now what? 22 multiply with 200 multiply with 200 into 900. This much divided with 28. So it will be, volume will be 2.8285 into 10 to the power 7 in mm cube, right? So we got the value for volume here. So we can write 2.8285 into 10 to the power 7 upon what? T is 8. E is what? 2 into 10 to the power 5. Okay. So we can erase this thing. Right. Also 5 by 2 minus 2 into 0.3. Excuse me. So del V will be, del V is given here 20,000. Right. So 1000 equals to, we can cancel this term, 10 to the power 5 with 10 to the power 7. So we will have 10 square. Next, these two with here 150. Okay. So now what we have, P into 50 multiply with 2.82, right, into 10 square upon what? 8. Now by converting this P to this side, so what we left? 20,000 with 8. Next 50 into 2.82 into 10 square into 5 by 2 minus 2 into 0.3, right? So what will be our P value? This P value will be 1000 into 8,000. Okay, so you will write it that 16,000 upon 50 into 2.82 into 100. So 14100 into 2 into 0.3, that is 0.6. 2 minus 0.6, that will be 1.9. This whole thing about calculation, if you are correct in calculation, so for these calculations we definitely need scientific calculator into 1.9. So our change in volume, that is del V, del V will be what? 2.15 mm. Okay, sorry, del V, it will be our P, 2.15 Newton per mm square. Okay, so what do we need to calculate now? In second question, here the question asks about calculate hoop stress. So here, How to calculate hoop stress? We have already calculated various times, that is hoop stress is denoted by sigma c, and sigma c is PD upon 2T. So now we have all these values. So what we have in case of our P? P is 2.15. 2.15 and our D is 20 into thickness is what? 8 mm. Yeah, right, 8. So our hoop stress will be 2.15 multiply with 20 upon 16. So our sigma c will be 2.68 Newton per mm square. Okay. In this question, what asked? About hoop stress. If the question asked about longitude, to calculate longitudinal stress, the formula for longitudinal stress is what? PD upon 40 by putting these formulas, and by putting the value of P, D and T, we can calculate what? Sigma L. So here in this question, what we have discussed, so you can take the screenshot of this solution. What we have asked and what the question we gave in this question, that if the change in volume is given, we can calculate the total volume. If change in volume is given, so we can calculate P. Of also if P is given, so we can calculate P, and del V is given, so we can calculate D or del D. So these all values are correlated with each other. So if one is not given, we can, by putting the formula of this, we will get the value. So in this class we have solved this type of numerical to calculate pressure and all. So I think you understand it properly. If any issue for the understanding, so you can comment me, and in our next class we will discuss lots of numericals again. So thank you so much.